back to our slides. Okay, so work with data tables in Microsoft Fabric. All right, so this is our next topic. How can we work with the data tables, data lake tables in Microsoft Fabric? Let's get started. All right, so let's first talk about the Delta Lake. Let's try to understand about Delta Lake. So Delta Lake is an open source storage layer that add relational database semantics to the Spark based data lake processing. Tables in Microsoft Fabric Lakehouse are delta tables, which are signified by the triangular delta icon on the tables in the Lakehouse user interface. Okay, so delta tables are schema abstractions over the data files that are stored in a delta format. And for each table, the Lakehouse stores a folder containing the Parquet data files and a underscore delta underscore log folder in which transaction details are logged in JSON format. Okay, so these tables, delta lake tables, these tables support these relational tables that support querying and data modification. And with Apache Spark, you can store data in delta tables that support CRUD operations, which is create, read, update, and delete operations. So, in other words, you can select, insert, update, and delete rows of the data in the same way you would in a relational database system. It also support for ACID transactions. So, like relational databases are designed to support transactional data modifications that provide atomicity, which is a transaction complete as a single unit of work. Then consistency, which is transactions leave the database in a consistent state. Isolation, in process transaction can't interfere with one another. And durability, so when a transaction complete, the changes it made are persisted. So Delta Lake bring this same transactional support to Spark by implementing a transactional log and enforcing specialized serializable isolation for concurrent operations. Okay. These Delta Lake tables also offer data versioning and time travel. Okay. So because all the transactions are logged in the transaction log, you can track multiple versions of each table row and even use the time travel feature to retrieve a previous version of a row in a query. Not only this, it also support for batch and streaming data. So while most relational databases include tables that store static data, Spark includes a native support for streaming data through the Spark structured streaming API. Delta Lake tables can be used to use as both sink, that is destination, and source for streaming data. Now, one of the most important thing is standard formats and interoperability. So, the underlying data for the delta table is stored in the Parquet format, which is commonly used in the data lake ingestion pipelines. Okay. So, additionally, you can use the SQL endpoint for Microsoft Fabric Lakehouse to query delta tables in SQL. Okay. So, this was about the Delta Lake. Now let's move on and let's see how can we create delta tables using code in Spark. Okay, so when you create a table in a Microsoft Fabric Lakehouse, a delta table is defined in the meta store for the lakehouse, and the data for the table is stored in the underlying Parquet file for the table. With most interactive tools in the Microsoft Fabric environment, the details of mapping the table definition in the meta store to the underlying files are abstracted. However, when working with Apache Spark in a lakehouse, you have greater control of the creation and management of the delta table. So let's see how to create a delta table from a data frame. So this is one of the easiest way of creating a delta table in Spark is to save a data frame in the delta format like we have done here. Firstly, here we have loaded the file into the data frame, and then we have saved the data frame as the delta table. Okay, then we can also use the Spark SQL. All right, so you can also create the delta table by using the Spark SQL create table statement. All right, and you can also save in the delta format. So this is the third possibility, is to save the data in delta format without creating a table definition in meta store. So this approach can be useful when you want to persist the result of data transformations performed in Spark in a file format over which you can later overlay a table definition or process directly by using the Delta Lake API. All right. Now let's see what is the difference in between the managed and the external tables. So in managed tables, the table definition in the meta store and the underlying data files are both managed by the Spark runtime for Fabric Lakehouse. Okay, so deleting the table will also delete the underlying files from the table storage location for the lakehouse. You can also create table as external tables in which the relational table definition in the meta store is mapped to an alternative file storage. Okay, so for example, the following code, it creates an external table for the file for which the data is stored in the folder in file storage location for the lakehouse. Okay, so in this example, the table definition is created in meta store. So the table is listed in the table user interface, okay, for the lakehouse. But the Parquet data file and the JSON log file for table are stored in the file storage locations. Right. Now work with the delta tables in Spark. So you can work with the delta table or delta file format files to retrieve and modify the data in multiple ways. So either you can use the Spark SQL. So the most common way to work with the data in delta table in Spark is to use the Spark SQL. You can embed SQL statements in other languages such as PySpark and Scala by using the spark.sql library. Alternatively, you can use the SQL magic in a notebook to run the SQL commands like we have done here. And you can also use the Delta API. So when you want to work with Delta files rather than catalog tables, it may be simpler to use the Delta Lake API, and you can create an instance of a Delta table from a folder location containing the files in Delta format, and then use the API to modify the data in the table. Okay. Now, data versioning and time travel. So, as we have already studied, that data versioning and time travel is an important feature of your Delta Lake tables. Okay, so we can use this time travel to work with the table versioning. Okay, so whatever modifications made to the delta tables are generally logged in the transaction log for the table. You can use the logged transaction to view the history of changes that are made to the table, and we can also retrieve the older version of the data, which is known as the time travel. Okay, and to see the history of a table, you can use the describe SQL command. Okay. Now, we can also use this delta table with the streaming data. Okay, so here a typical streaming process solution, it involves constantly a reading of streaming of data from a source, optionally processing it to select specific fields, aggregate and group values, or otherwise manipulate the data. Okay, and writing the result to a sink. So Spark include native support for streaming data through Spark Structure Streaming, an API that is based on the boundless data frame in which streaming data is captured for processing. All right. So a Spark structured streaming data frame can read data from many different kind of streaming sources that can include network ports, real-time message, brokering services such as Azure Event Hubs or Kafka, or file system locations. Okay. So working all right. So working with the Delta Lake as a streaming source or streaming data. So Delta Lake, it supports streaming data ingestion and processing. It can effectively handle real-time data stream by providing scalable and fault-tolerant ingestion and processing capabilities. And streaming data can be continuously appended to a Delta Lake table, and the changes are automatically made available for querying. Now we can also write streaming data to the Delta Lake, as you can have a look on the given code for that. Okay. So now while writing, you can use the structured streaming API in Apache Spark to write the streaming data to a Delta Lake table, and Delta Lake support the append mode, okay, where the new data is appended to the table. You can define the input source, schema, and the output mode to configure the streaming job. Now we can also handle late data and updates. So Delta Lake, it provide mechanism to handle late arriving data and updates in streaming scenarios. And you can specify a watermark to discard the old data and handle late arrivals. Okay, you can also monitor and optimize streaming jobs. So monitoring the progress and performance of streaming job is essential. Delta Lake is essential, and Delta Lake provide features like progress report, metrics, and transaction log management to help monitor and optimize streaming job. Okay, so this was about using our delta table with the streaming data. Let's have a quick look on the demonstration part of delta table. So let me just switch my screen. So in this table, we will learn how to use delta table in Apache Spark. So from here, I will select Synapse Data Engineering persona, and we will be creating a workspace here. So from the left hand side menu bar, we will select workspace and we will create a new workspace. Okay, apply. So we can see that delta underscore workspace one has been created. So now it's time to create a lake house. So for that, we'll go on the home page and we'll create a lake house. Okay. Now inside the files folder, I will upload a file. So first I will create a new subfolder and I will give it a name as product. Inside the product subfolder, I will just upload a file. So I will upload product.csv file here. Okay. So if I click on the products folder, I can see product.csv file has been uploaded. Now we will explore the data in our data frame. Okay, so for that, we will click on open new notebook. All right, and here from the product.csv, we will just load the data to the Spark. All right, let's run it. So we can see the data. Okay, you can see the output, which is showing the data of product.csv file. Now we will create a delta table. So we can save the data frame as a delta table by using save as table method. So let's first create a managed table. Okay. So let us just add a code cell, and inside it, let me just type the code. Okay. So I have copied two codes. One is for creating a managed table, and the second one is for creating the external table. So let's look at the code which we have used to create manage table. Now let's run it. So command succeeded. So now let's refresh the tables. And here we can see a managed product data table. Now we will create an external table. So we will just explore this code. Okay, now it is here we have to copy the ABFS path of our files folder. So for that, we'll copy the ABFS path and we'll just paste it here. Now let's run it. All right, so again, we will refresh and we can see an external product full table as well. And also in the files folder, I can see an external underscore product folder that has been created for the tables data files. Okay, now let's compare these two tables. So for that, let me add a code. So in the result, if we look at the location, let me just expand it. Expand it more. Some more. Okay, so we can observe that the location property for the table, and here the path has one lake storage for the lake house, and it is ending with table slash managed underscore products. All right, now let's add one more cell and let's explore the external table. Okay, let's just run it. And here, if I look at the location, so again, I have to expand it. Okay, so in this result, the view the location property, and here it should be a path to the one lake storage for the lake house, and it is ending with the files external product. Okay, so files for managed table are stored in the tables folder in the one lake storage for the lake house. And in this case, a folder named managed underscore products has been created to store the Parquet files. And the delta log folder for the table that we have created. Now we'll add another cell and we'll just drop the two tables. Okay, and now just refresh. So we can see that the tables have been dropped and there is nothing inside the table list. Now let me refresh files also. Okay. So here we can see that external underscore product folder has not been deleted. Okay. And if we select this folder, we can see that the Parquet data file is still there and a delta log folder is also there. All right. So this is how we can create a manage table and external table. Now we will use SQL to create a table. So for that, let's add another cell. Okay. Okay. So it is succeeded. Now in here in the table menu, if I refresh, we can see a product table has been created. Okay. And basically this table is created and it is matching the original data frame that was saved inside the external product folder. All right, now we'll add another cell and we'll try to explore the data of this table. Okay, so we can view the data of the table. Okay, we can also explore the table versioning inside our delta table using our delta table, and we can also use delta table for streaming data, but because of time constraint you can do that in homework. All right, so for now let's go back to our slides. All right. So now we are done with our today's session and it's time to wrap up the session. So let's recap what all things we have learned in today's session. Okay. So we have learned, we started our session by the discussion of the fabric lake house. So we have learned the foundation that fabric lake house is a foundation of data engineering. Then we have also learned about the Mendelian architecture and how it offers a structured approach to logically organize the lakehouse data, and it contains different layers to store the data, to store the raw data, transform data, and the final data. All right, then we work with the data using the Spark and Fabric notebook. And lastly, we created a managed table using Spark, and we performed the lab for the same as well. Okay, so I hope this session was fruitful for you. Now, let's go ahead, and these are the links for your further reading. If you want to refer the content of the slides that we have learned today, you can refer these links and you can go ahead and read more about the topics that we have learned today. So with that note, I would